In this lesson, we are going to continue looking at patterns. In the last lesson, we looked at patterns from different diagrams. We want to also look at patterns from tables of values and graphs. So here we have an example of a person, Elvis. He makes a box of fudge and he works out the cost of making the boxes by using a pattern. So the number of boxes made is indicated in the X column, which is the independent variable, and the total cost of making the box is the Y value, and that is dependent on the number of boxes that we make. So one box costs $6, two boxes cost 10, 3 costs 14, 4 costs 18, and so on. So what pattern do we see in the table? Well, we can look at how the Y value is increasing. So if I go from $6 to $10, I've increased by $4. If I go from $10 to 14, I've increased by 4, 14 to 18, increased by 4, and so on. So every time I make one more box, so as my X value increases by one more box, my cost increases by $4. So for each box, the cost increases by $4. So this would be considered my rate of change. My rate of change is $4 for each box. So the equation, remember, it is linear because the rate of change is constant, right? We're going up by the same amount. So if it is linear, so it is a linear relation, it's going up by the same amount, so it's y equals mx plus b, where m is the rate and b is the initial value. So in this case, the rate is $4 for each box. The initial value, we want to go back to 0. So since we're increasing by 4, we can decrease by 4 to get back to 0. So 6 minus 4 would be 2. So the initial value is 2, and this is my pattern. So the cost to make 20 boxes, all I would have to do is each box costs $4, plus we started with 2, so that would be $82. Sometimes we're given a graph, so we can do the same pattern in that we're looking for the rate of change in the initial value. So the initial value is always at 0. So I can see that the initial value is 0, 0. And then we want to find the rate of change. So we can do the rate of change between any 2 points. So I want to make sure I'm at a grid mark where the points intersect. The problem with this one is there's no values on the grid, so I can't tell the exact value, but I can see that it is a positive correlation. And that's because as temperature increases, the sales increase. So it looks like as it gets warmer outside, I sell more ice cream. That is the only thing I can determine from this graph. There are no values on the x and y axis, so all I know is there's a positive correlation. There's a positive rate of change because as x increases, y increases. So we can't determine the specific rate of change, but we can overall look at the positive correlation. And then sometimes we have a description of a situation. So in this situation, Blake has a bank account. We are told that his initial deposit was $125 and that every month he's putting in $40. So each month he's putting in $40 and the initial amount was $125. So the rate of change is $40 each month. That's what's changing. The initial value was $125. That was the initial deposit. And it is linear because he's putting in the same amount every month, so it is a constant rate of change. So we're looking for the rate and the initial value. So we know the rate of change was $40 each month, and he started with $125. So how much would he have after 6 months? We can just put $40 each month for 6 months is $240, plus he started with $125. So $240 plus $125 is $2,365. And then we can also look at how long it would take to accumulate $525. So we know the pattern. So we want to know, what if we ended up with $525? How many months would that take? So we want to solve for x, the number of months. So let's get rid of the initial value. So we'll subtract 125, which leaves me with $400 at $40 each month. So we'll divide by 40 to determine the number of months. So $400 divided by $40 each month means it would take 10 months to save that much money. Okay, here we have another table of values. It is temperature at a certain time of day, and we want to know the rate of change. So when we look at rate of change, we want to look at two things. We want to look at how the independent variable is changing. Oops. Put that in the wrong spot. So delta y over delta x. So how is the dependent variable changing compared to the independent variable? So in this table, this is x, this is y. So we're looking at how is this changing. So if I go from -10 degrees to -6 degrees, I've increased by 4 degrees, and that was over 2 hours. If I go from -6 degrees to 0, that has increased by 6 degrees, and that was over 3 hours. And then 0 to 6 was 6 degrees over 3 hours. So the rate of change was different each time. So 4 hours, 4 degrees. So 4 degrees Celsius over 2 hours in the first one, 6 degrees Celsius over 3 hours, and then 6 degrees Celsius over 3 hours. But in each case, if we reduce, each one works out to be 2 degrees Celsius per hour. So that's my rate. Every hour it's increasing by 2 degrees Celsius. So just make sure that you're comparing the y to the x each time. That is the same question. Let's skip that. Okay, here we have a graph, and we want to find the rate of change. So this is the cell phone bill that is being paid by the parents, and we want to determine how much money has been saved each month. So it gives us some values. So it says at 0, 500, and at 4 months she saved $300. So when I'm doing rate of change, if I want to know what I'm comparing, I'm looking at how is y comparing with how is x comparing. So on the y-axis we have money saved, and on the x-axis we have number of months. So that's what our rate of change is determining. It is determining how much money I've saved each month. I'm looking at, as I go from point to point, how is the y changing and how is the x changing. So I can count. If I want to, on the grid, I go from 500 to 300, which is going down by 200, and that took 4 months. So the money saved was $200 over 4 months, or $50 each month. You can also do it if you want to use 2 points. The initial point was 0, 500. That's my x, my y. The next point is for 300. So you could also look at the change in x and the change in y as subtracting the two y points and subtracting the two x points. So it would be 500 in the first y, 300 in the second point. 0 was the first x, 4 was the second. So 500 minus 300 is 200. 0 minus 4 is minus 4, which is also 50. So you can count on the grid, or you can take 2 points and subtract the y's and then subtract the x's. So each case you're going to get the same result, minus $50. So it's a negative correlation. It's reducing by $50 each month. Okay, so here is 4 different flight options and 4 different tables of values. So what we're measuring is number of days away, which is my x, and total cost is my y. So we want to match the table with the initial value, which is the flight. So that's the cost of the flight. So it says here the initial value represents the flight cost and the rate of change represents the cost per day. So how are we going to figure that out from a table? Well, what we want to determine is, let's look at rate of change first. So rate of change is how is the y increasing compared to the x. So in the first table, the total cost is increasing by $250, and that was for 2 days. Let's see if this is consistent. So we do 1520 minus 1145 is 375, and that was for 3 days. Okay, so let's see what that rate of change is. So 250 divided by 2 is 125, and 375 divided by 2 is also 125. So the rate of change for the first table is $125. So it looks like D matches with that table. The initial cost, we could just go back to 0. So if we have 3 days and it is 125 per day, we can go back to 0. So we'll subtract 375 for 3 days from 895, and that gives us $520, and that's what is the flight cost in D, so that is correct. Okay, let's look at the next one. So let's do this in a different color. So 2 days has an increase of $965 minus $635, so that's an increase of $330. And 4 days has an increase of $1625 minus $965, which is $660. So delta y over delta x is $330 for 2 days, or $660 for 4 days. So that is $165 per day. And then if I wanted the initial cost, so it looks like it's going to be, this one is $165 cost per day. The initial cost, so if I go back down to 0, I would have to subtract 165 from 635, because it's 165 per day. So 635 minus 165 is 470. So that is correct with the flight cost. So this one goes with that table. All right, let's do green for this one. So we've got $999 minus 687 is 312, and that was for 2 days. And let's do one more just to see if we're consistent. 1779 minus 999 is 780, and that was for 5 days. So delta y over delta x is 780 for 5 days, which is 156 per day, or 312 for 2 days, which is also 156. So this rate of change is 156, which goes with this one. And then by process of elimination, that last table would go with C. So you want to look at the rate of change. How is the y changing compared to the x? In this question, we want to match the line with the correct equation. So we could start by looking at the initial value. We have two of them have an initial value of 200. And two of them have an initial value of 500. Okay, so this one has an initial value of 200, and so does this one. Okay, it says right here 200. So these are C and D. How do I know which one is C and which one is D? Well, C is steeper, which means it has a larger rate of change. It's a steeper line. I don't really need to calculate what it is. I just know it's steeper than D. So this one will go with C because the rate of change is 25, and this one would go with D because the rate of change is 20. I could find it on the graph. I could take 2 points, so I could say, well, C has a rate of change of 300, and so if I look at this rate of change, it's going up by 100 each for 4 weeks. So I could find it. If I wanted the exact number, I can see that the y is changing from 200 to 300, so it's going up by 100, and that took a value of 4 weeks. All right, so it went $100 increase in 4 weeks, which is 25, which I knew from the graph it was 25 just because it was a steeper line. So you could actually calculate it if you want, but I know that C is steeper than D, so I know C would have a larger rate of change than D. And I could do that with A and B as well. A and B have an initial value of 500, so I can see that here. Which one is steeper? A is steeper. So it has a larger rate of change. So if I were picking between A and B, I would say this is A because it's steeper, and this is B because the rate of change here is 25, the rate of change here is 20.